Good morning students, I am Krishna Rao. I am Assistant Professor in CSE Department, Institute of Aeronautical Engineering. So, today we will discuss the input buffer system. The lexical analyzer, the main task is reading the source program, character by character, and produce the streams of the tokens. So, the main task of this lexical analyzer is reading the characters one by one from the memory and produce a sequence of tokens. So, here this reading of character by character is time consuming one and it's performing reading for memory. So, to avoid more number of access to the memory, we will use the concept of input buffer system. We use the concept of the buffer system. For this buffer system, we use the concept. It uses two pointers, lexeme begin pointer and forward pointer. Right? Here, the lexical analyzer, the compilers will use the concept of buffer system, input buffer system. To use them more efficiently, it uses the lexeme begin pointer, forward pointer. It uses lexeme begin pointer, forward pointer. So, during the compilation, the program resides in hard disk. So, execution of the program resides in the main memory. So, here, initially, the begin pointer, forward pointer both will indicate the first character of the input buffer. So here we will read the blocks of information from the secondary memory to main memory. So that, and we'll store in this input buffer. Then we read the character by character and produce lexemes. So, after completion of forming the lexemes from this data information of the input buffer, we will once again read a block of information from the secondary memory to main memory. And we will generate another sequence of tokens. Then, here, instead of reading by reading character by character from the backend, from the secondary storage to main memory, we are reading a block of information. So that for the main advantage of this input buffer, we are reading once and we will generate a sequence of tokens from that information. So initially the lexeme begin pointer, forward pointer will indicate the initial. Then here forward pointer will be forwarded to find the end of the lexeme. Right? So finding the end of lexeme. So int. Then when it found the empty space, delimiters, then it will group the characters between the begin pointer to forward pointer as a single lexeme. So, it will indicate the end of the blank space. It indicates as the lexeme and simply it encounters the int is identified. Right? Here, this forward pointer will be moved at the white space. When forward pointer encounters white space, it ignores and moves ahead. After that, both the begin pointer and forward pointer are set to next token. Right? After generating one token, then both are updated to the represent the starting of the next token. Right? So now the token of integer is generated. Now both are representing pointing to I, and it will generate a sequence of tokens. The input character is the read from secondary storage, but reading in this way from the secondary is costly. Hence, buffering technique is used. A block of data is first read into buffer using a single system call, then second by lexical analyzer. Here, there is a drawback in the first one buffer scheme. So now we have seen one buffer scheme, but till there is a drawback in the one buffer scheme. To overcome that, we use the two buffer system. So these are the two methods that are available in the input buffer system. So here, if we observe in this one, if the token is completely read and stored in this buffer, it will generate the token correctly. But if some characters of the token are read in the first system call, in the first filling of the buffer, then what happened? The begin pointer will indicate the starting of the token, a lexeme. But forward pointer, it is unable to find the end of the lexeme. Before that, it will point that end of the buffer. So what happened? The complete information is removed and replaced with another block of information. So the last characters which are not constructed as a lexeme will be lost. And the initial characters of this second buffer data will also be unable to find correct lexeme or correctly generated the token. So we are missing some information in constructing the correct tokens. So that is a drawback in the one buffer scheme. So to overcome that one, we use a two buffer scheme, right? So this is a one buffer scheme. In this scheme, only one buffer is used to store the input string. So if we observe in this one, here int is initially constructed. When it comes to find end of this one, it is unable to find this end of the lexeme one. So here what happened? It encounters the end of the buffer. So it will reveal this information with the next coming information, another block of information. So here the one will not be generated its respect to token. There is a main drawback in the one buffer scheme. So the problem with this scheme is that if lexeme is very long, when it crosses the buffer boundary to scan rest of lexeme, the buffer has to be refilled. This makes overwriting the first of lexeme. So some data is missing before generating the proper tokens. So to overcome that one buffer scheme, we use the two buffer scheme is to store the input string. So we use the two buffer scheme for this one. So when end of the current buffer is reached, the other buffer is filled. Right? When end of the current buffer is reached, the other buffer is filled. So here the only problem with this method, if the length of the lexeme is longer than length of the buffer, then scanning input cannot be scanned completely. Right? If we are using two buffer system, but it is its length will more than this two buffer system also, then we are unable to find its length. So in the previous one, if you use a one buffer system, the one is unable to find its respect to token to be generated. So now the lexeme begin pointer indicating 1 and forward pointer indicating semicolon. So this one will be generated successfully as its token, right? Then semicolon, other one. So this is the advantage of the two buffer system. When the first buffer is completely filled, when the first buffer is completely filled, then simply it refills the second buffer.
So, yes, can you just start doing
ఆన్లైన్ క్లాసెస్ కోసం
వీడియో యూట్యూబ్
నోట్ చేసి ఆడ వచ్చేస్తుంటది మళ్ళీ ఎడిటింగ్.
సో ముందు వాళ్ళు పీపీటీ తీసుకొచ్చుకొని ఇక్కడ క్లీన్ చెప్తుంటారు సార్. సో పీపీటీ ఏం చెప్తారు అది మొత్తం రికార్డ్ అవుతుంది, వాళ్ళు చెప్పేది మొత్తం రికార్డ్ అవుతుంది. సో స్క్రీన్ యాజ్ వెల్ యాజ్ వీడియో ఫేస్ మాట్లాడుతున్నాం, ఆ రెండు డేటా తీసుకెళ్లి మనం బయటకి వెళ్ళి ఎడిట్ చేస్తాం.
ఇది లైవ్ స్ట్రీమింగ్
లైవ్ స్ట్రీమింగ్ పెట్టలేదు,
తర్వాత ఎడిటింగ్ చేసి
సో దానిలో కొన్ని లైక్ కొంతమంది కోట్ వేసుకొని చెప్తారు, కొంతమంది అలా వేసుకొని చెప్తారు.
లైటింగ్, సౌండ్ అబ్జర్ప్షన్,
మానిటర్ కమ్ ప్రాంప్టర్ కూడా ఇదేనా? అవసరం అనుకుంటే ప్రాంప్టర్ అవసరం లేదు.
అవసరం లేదు సార్, దీనిపై రాయొచ్చు, దీని మీద రాయొచ్చు. అంటే ఏం చేస్తారు
రెడ్ లైన్ నుంచి
ప్రిపేర్ చేసుకున్న నోట్స్ ఏమైనా ఉంటాయి దాంట్లో
వచ్చేస్తారు. సో పీపీటీ మనం నీట్ గా తీసుకురావాలంతే. మనం ఏం చెప్పాలనుకుంటున్నామో అది పీపీటీలో నీట్ గా తీసుకొస్తే, ఎంత నీట్ గా తీసుకొస్తే మన చెప్పేది అది నీట్ గా కనిపిస్తుంది, అంత నీట్ గా కనిపిస్తుంది. ప్రతిదీ వాళ్ళు తీసుకొచ్చే డేటాను బట్టి ఎడిటింగ్ చేసేస్తాం. ఇక్కడ ప్రీమియం ప్రో యూజ్ చేస్తున్నాం. లైక్ ఇది సార్ మాట్లాడుతుంది, కూతురు మాట్లాడుతుంది, ఇది పీపీటీ బ్యాక్గ్రౌండ్. సో రెండు మిక్సీస్ ఎడిటింగ్ వాయిస్ ప్లస్ అండ్ రాసింగ్ మిక్సీ పక్కన వచ్చేస్తుంది. లేయర్ కట్ చేస్తాం, ఏమైనా డిస్టర్బెన్స్ ఉంటాయి. పొజిషన్ ఎక్కడ పెట్టేసి మధ్య డిస్టర్బెన్స్ ఉంటే అదే కట్ చేసేస్తాం. అదే పీపీటీ నుంచి ఆ అరేంజ్ చేసేసి
So here the begin pointer will indicating 1 and the forward pointer indicating semicolon. So the complete token for the 1 will be generated. When it found the end of the first buffer, it refills the second buffer. If it is found the end of the second buffer, then the first buffer is refilled. So by using this two buffer system, we can generate the complete sequence of tokens. So we will overcome the drawback in the one buffer systems where we are missing some information before generating the lexemes and tokens. Right? So that is the advantage of the two buffer scheme. Right? So initially both the begin pointer, file pointer are pointing to the first character of the first buffer, and the file pointer moves towards the right in search of the end of the lexeme. As soon as blank character is recognized, the string between the begin pointer and forward pointer is generated as a token. Right? When boundary of first buffer, we use the end of buffer character should be placed at the end of first buffer. So when it encounters the forward pointer encounters the end of buffer character, then it will fill the second buffer. When it found the end of buffer, it will fill the first buffer. It will be continued. Right? So similarly, end of second buffer is also recognized the end of buffer mark present at the end of second buffer. When file pointer encounters the first end of file, then one can recognize the end of the first buffer and hence filling the second buffer is started. Right? In the same way, when second end of buffer is obtained, then it indicates the end of the second buffer. Alternatively, both the buffers can be filled up until the end of input program and stream of tokens is identified. And stream of tokens is identified. So this end of file character used to indicate calling sentinel, right? Which is used to identify end of buffer. The sentinel which is used to identify the end of buffer. So here forward equal to forward plus 1. When forward is pointing to end of buffer, then forward at the end of the first half, then begin reload the second half, and we'll go on. Then if forward end of the second half, then begin reload of the first half, and move the forward beginning to the first half, and else the end of file within the buffer signifying end of the input. Terminate the lexical analysis and end. So using this concept, we'll use the second buffer system for generating the lexemes. So I'm closing this topic now. The input buffer system. We'll continue the remaining topics in the next class, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.